man, I wonder what's faster, light waves or sound waves? Cause when I talk, I can hear myself. But when I look at the sun, I see the light. When I talk, I hear myself. So, therefore, I think sound waves are faster.
Well, this old man got one hell of a genius of a horse. So let me teach him the true ways of sound waves and light waves. Come with me to my room. You too, buddy. Alright, so this old man is gonna teach you the differences between sound waves and light waves. One of the many different things about it is obviously the type. So light waves are an electromagnetic wave, as you can see over here. It's also a radiation that comes through, and we can see it and observe it by the human eye. Another thing is that light doesn't need a medium to pass through. That's why we could see light from space, because it can pass through a vacuum. One more thing is that it's a transverse wave, so it's perpendicular to the motion that sets it off. Light wave is way faster than sound waves. Why, you may ask? Even though there are a lot of different mediums we could compare them in, light waves always win at a whopping 3 multiplied by 10 to the power of 8 meters per second. Isn't that crazy? Cool. Alright, let's get into sound waves. So the main thing about sound waves, or this definition obviously, is that it's a mechanical wave, unlike light wave. And it also is basically a pattern of disturbances caused by movements of energy or how I said in the medium, because it needs a medium to pass through. That's why we can't hear sound in space, obviously. Now, my horse is an idiot because he said that sound is faster than light. Well, he's wrong. 43 meters per second compared to light waves, that is nothing. Of course, these movements and speed patterns change according to its medium, but for the most part, light wave is always faster. And also, one more thing about sound waves is that it's a longitudinal wave. You can see here the differences between the two. That longitudinal is actually parallel to its source. And now that we discovered our differences between sound waves and light waves, let's talk about one more bonus thing. It's a diffraction.
But Sigma, what's a diffraction?
Don't worry, horse, I got you. So, what is a diffraction, you asked? Let me tell you, diffraction is very simple to understand. It's when a wave is going and then it hits a wall, as you can see right here. It either diffracts, which makes it bounces off the obstacle. Doesn't have to be a wall. Or it doesn't, because it has minimal diffraction. Now here's the thing. Sound has a lot of diffraction. How, you may ask? It's because, as you can see here in the picture, sound waves do bounce off obstacles most of the time. That's what makes echo. So we can hear the sound twice. But what about light? Light has minimal diffraction. That's why we could kind of see dark corners in rooms, even though there is minimal light in the middle that highlights the room. And there you go. Now that you know the differences between light waves and sound waves, you could go around flexing that knowledge all over your parents or friends. You're welcome. Bye.